Hello everyone, welcome back to the channel. Today we are going to solve this question called Fall Down from the Codeforces Division 4 round, which is G, the seventh question. So relatively easier than other Division 4s. So let's take a look at the question. So we will be given a grid with the characters having n rows and m columns, each character being dot, asterisk, or this O. So dot depicts the empty space, asterisk depicts the stone, and O depicts the obstacle. So uh, grid is given like this, and stones fall down means like you can think them of winter snowflakes are falling down one upon the another, or you can model it as the Tetris blocks only having only one by one grid, and O is the obstacle means obstacles will be fixed and they won't be moved. So the stone which is above the obstacle will be coming down most closest means uh, just above the stone, it can't go below the stone. So that is it, and we have to simulate the process, not the whole process, step by step. We just have to give the final grid. How will it look after the process ends? So let us take a look at this sample test case 1. So 6 rows and 10 columns. So here it is. So in this process, what will happen is that take a look at this first row. First row isn't having any stones to fall down, so it will remain as it is. And in second column, so you can see that this is the obstacle, it will remain at its place, and this asterisk means this stone will descend down to this spot. Okay, and this spot will be filled with this empty dot. Okay, so it will come down till the second last uh, row at this column, and this snowflake, or what you can call stone, this will come till here because this place is already filled by this stone, and this place is already filled by this stone. So this stone will be able to come till the third row of this particular column. So similarly, take a look at this third row or third column. So in third column, uh, nothing is there, it seems. So here in third column, nothing is there. So nothing, no stones or no obstacles are there. So let us take a look at this fourth column. Fourth column, only this star and this obstacle. Oh, this star and nothing else. So this stone will descend down to the lowest point, which is which is descending till here. So till here, an obstacle will remain at its place, and this stone will come to the closest of the obstacle. So here it is. So that is how the grid is transforming. So we have to finally code it up, means this is implementation based question. So what I will do in the code is that for every column, I'll declare position. What is the position doing? So position is like, suppose this stone is there. So what if I encounter the stone, I'll start traveling from the bottom, and if I encounter the stone, then how far down it can go, this will be contained in this variable position. So for this stone, position will be, what will be it, n minus 1. Okay, for this stone it will be n minus 1, for this stone it will be n minus 2, and for this stone it will be n minus 3. So like that we have to code it in the way that position gets updated every time when we encounter the obstacle or the stone or the empty place. So when we encounter the obstacle, we have to update position to some upper value than the row which contains the obstacle. Okay, because what you call stones cannot go below the obstacle, right? So that's why. So let's take a look at code. How is it implemented? So yeah. Uh, Input is getting completed here. I'm using one based indexing. I feel more comfortable in that. So setting position to n. So I'm using this set called helper. So this for loop will account for the columns, and this for loop will account for the number rows, means climbing upwards. I'm starting from the bottom. You can see that I is equal to n. So if position is equal to 0, then break. So if position becomes 0, then uh, there is no way that we can put any of the stones there, right? So that's why breaking. And if there is a stone encounter, and if helper dot size is 0, means helper will contain the positions. So why helper, you can wonder. So why helper is that, suppose these are the empty blocks, this is the, you can call stone, suppose this is also a stone, and this. So when I store position is equal to n, when I encounter this rock or the stone, I will improve its position by this thing, what called n minus 1, right? So because it is just above that, so sorry for the disturbance, and uh, I will update it to n minus 1. And what this store will store is that, okay, helper set will store is that it will store all the possible positions where this rock can go, where the coming rock can go. So I will store the positions in this helper set. So yes, so storing positions into the helper set. And when we have to, when we there is need to assign this stone a value, means final value in the grid, we will use position is equal to star helper dot r begin. R begin, star means it returns the value, and r begins means it returns the highest value in the set. Okay, highest value in the set. Then we will assign it to the star, that position in this jth column to the star, and the position at which star was present, means star or asterisk rock was present, to the empty space. Then we have to remove that position from the helper set, because any other rock cannot occupy the other rock's position, right? So that is what this erase is doing. And finally we will insert I. Why inserting I? Because when asterisk moves from this I to position, so this ith row in the jth column, the entry in the ith row of the jth column, it becomes empty, right? So we have to push or insert it into the helper. So if matrix of I comma j is O, means if there is obstacle, then we have to erase all the elements in the helper set which are below that position of the obstacle. So because the stones above the obstacles cannot go below the obstacle, right? So that's why this thing is done by storing this elements in the store vector, and then one by one erasing them from the helper. And if finally it is empty space, then inserting it in the helper, and doing this for every column and every row. So yes, that is it. This will finally stimulate our process or simulate our process, and we will have final result, finally outputting it. I is equal to 1, I is less than equal to n, j equal to 1, j is less than equal to m, and outputting ma of I comma j. So that was it. Hope you enjoyed solving the question and listening to the solution as well. Thank you for watching the video. Consider liking the video, stay subscribed to the channel. and hope I see you again watching my videos. Goodbye. Take care.